Hi there, my name is Will and today I'm going to walk you through the difference between parallel and sequential tasks inside of Kestra. Now, sometimes you want to be able to build complex workflows where you can run things in parallel or run things sequentially. But you're probably thinking, tasks are already run sequentially in Kestra by default. What's the purpose of having a sequential task as well? Now, I'm going to walk you through a few examples of where this can be useful in combination with the parallel task to be able to build very complex workflows to suit your needs. Jumping in here, I've got a workflow here that's using the parallel task. And as you can see here, we've got 6 tasks that are going to run in parallel at the same time. But there is a catch. We've got this concurrency property set here that is set to 3. And that means it's only going to run 3 of them at a time to help manage performance in certain scenarios. So as you can see, all of these tasks are going to run an echo and then a sleep command in a shell process. So this is just going to simply sleep for a second. Now, if I execute this, we'll see the first 3 run and then the next 3 run. This is super useful if you want all of these to run in parallel and you haven't got a preference on which ones finish first and if none of them depend on one another. So let's have a look at that in action. And as you can see here, it's now got the parent, which is the parallel task, and we can see that the first 3 of those tasks run exactly at the same time, and then the next 3 run afterwards once that concurrency factor comes away. Now, if these don't necessarily take the same time and maybe one of them takes a little bit longer, then as soon as those slots free up, the next tasks will start to fill them. We can see that if I change some of these to be sleep for longer, so we'll change one of those to sleep for a little bit longer, and what we'll see here is that 2 of those tasks will finish, one of them will continue to wait, but then we'll see 2 of them begin while we wait for that next one. In fact, what actually happened here was the first 2 finished, the next 2 started, and because we were still waiting for that original one to finish, the third one was able to have a free slot to then finish as well. So that gives you an idea on how that concurrent property works so that you can use that inside of your flows to manage performance. Or you want to use it to prevent having one system be interacted with by too many tasks at the same time. Maybe you're trying to connect to a database or SSH into a system, and you only want to have a certain number of requests made at once to not overload the system. Now, this task uses the sequential task. Now, while flows are naturally sequentially executed, this task allows you to then specify groups of tasks to run sequentially inside of that parallel structure. So as you can see here, we've got our parent task here. That is our parallel block that we had previously, which we can see here. But now we're using the sequential block here to group together 3 of those tasks. So this is useful if you've got multiple tasks that you're relying to depend on one another. Maybe you're making a request, then a Python script's going to process that request, and then maybe you're going to load that into a data warehouse. You can then put that all together inside of your sequential block and then run multiple of those sequential blocks in parallel to then make sure that you can get exactly what you're after. So if I press edit, what we'll see here, and I'll just make that a little bit bigger, you'll see that we've got the sequential block here, and then inside of that we've got the first task, the second task, and the third task, which means that compared to earlier, where if we go to that Gantt view and we can have a little look to see at how this was able to execute multiple things at once, what we're going to see with the sequential one is it's only going to run the whole block as a single unit. So even though maybe one of them will finish first, it doesn't mean that T6 at the bottom here will get a chance to execute just because sequential 1 has finished. So let's have a look at what that looks like in action to help us visualize what's going on. And as we can see here, we're seeing that it's running in parallel. And as you can see, 2 of those tasks are running in parallel for each of those stages, because it's worth noting that sequential 1 and sequential 2 are identical. So in theory, they should take as long as each other to run. And so we can see that the sequential blocks run just like the parallel, and we can see the 3 tasks inside of them run as well, rather than seeing what we saw a little bit earlier. And in fact, I'll go back in execution. So instead of seeing it like this, where we've got 3 of them running at the same time and then the next 3, they're running one at a time, but because those 3 are in groups, we're seeing that it's running technically 2 at a time. Now, if I was to go in here and modify some of this, so let's say sleep that first task for 5 seconds, that's now going to cause a huge bottleneck to sequential 1, because now the rest of the tasks cannot run until that 5 seconds is done. So as you can see here, sequential 2 is done, but now we had to wait for these later tasks in sequential 1 to be able to run because of the fact that we're asking it to run things sequentially. So this is great if you've got a scenario where you've got multiple tasks that you want to run and you want to maybe run those same tasks in parallel a number of times. But you need to make sure that the group of them runs sequentially because they depend on one another. Perhaps you're passing outputs between them. So this is really good for that. But if you're running just a bunch of individual tasks and you don't really care what order they get run in, as long as they all get run ideally at the same time and as quickly as possible, then just using the parallel block on its own is very, very powerful. So it is worth noting that the sequential block is probably not to be used on its own in isolation because tasks themselves already run in parallel, but it can be really useful when combining it with other flowable tasks to have very strong orchestration logic inside of your workflows. Hopefully you found that useful and you're going to start using the sequential and parallel task inside of your workflows. I'd love to understand how you're going to use these. So let us know in the comments below what you're doing with them, or you can let us know in our Slack community as well. And while you're at it, make sure to give us a star on GitHub.